Hello everyone, today we'll be going over section 7.7, independent and dependent events. What do they mean? Okay, first of all, independent events. Two events A and B will be independent if the probability of A occurring does not affect the probability of B occurring. Let's say, for example, if you toss a coin twice. The first time you toss a coin, you will have two possible outcomes, either a head or a tail. Well, if you toss it twice, the second time, you're still gonna get either a head or a tail. It doesn't change the outcome to just one or two, three outcomes. Okay? And another example would be spinning a spinner. So for example, if you have a spinner that's like you got two sides. One's maybe let's do three equal sides or four. Let's say A, B, C, D. Let's say these are equal parts. Now, you spin it once, you will get the outcomes is one of these four letters. If you spin it twice, the outcome is still one of these four. The outcome is still these four letters. It doesn't change. Right? So the first time you spin it does not affect the second time you spin it. Whereas for dependent events, the probability of the first event or the first event will affect the probability of the second event. So for example, if you have a box of marbles or a bag of marbles, you can let's say there are 10 of them in the box. Now, if you randomly choose one of the marble, and that's the first event, you choose one from the 10. Now, you don't put it back. So how many marbles are there left in the box? Well, there are just 9 marbles left in the box, right? So the second event then is to choose another marble from the remaining 9 marbles. Now, do you think the first event affects the second event? Well, of course it is, because choosing one marble from the 10 will give you a probability of 1 over 10. Okay, the probability of choosing 1 from 10 is 1 over 10. Now, if you choose one from the remaining, then the probability of choosing one marble is 1 over 9, because there's only 9 marbles left. So that will be dependent event. The first event affects the second event. Now my question is, if you choose the first marble, if you choose a marble the first time and then you place it back into the box and choose it the second time, does it affect the second time that you choose it? No. If you choose the first marble and replace it back into the box, then you still have 10 marbles in the box, and the chance of choosing one marble, it will be 1 over 10. So if in that case, then it will be independent events. Okay. So without replacement, without putting it back, it will be a dependent event. With replacement, if you put the things back, then you'll be independent events. Okay, now let's take a look at our first example here. A cafe has a lunch special consisting of an egg or tuna sandwich, so E or T, milk, juice, or coffee. We use the first letter to represent each of them, and a brownie or pie for dessert. Okay, so you have a sandwich, you have a drink, and you have a dessert. Now, one item is choose from each category to make the meal. So first question is use a tree diagram to list all the possible meals. So first of all, you're choosing a sandwich. Well, you can either choose the egg sandwich or you can choose the tuna sandwich. That's the first thing you choose. Now the second thing you choose is the drink. If you choose the egg sandwich, you can choose 3 drinks. You can choose a milk, a juice, or a cup of coffee. Well, same for tuna. If you choose a tuna sandwich, you can also choose these 3 drinks. And the last one is is the dessert. So you can have a brownie, or you can have a pie. Whoops. So if you choose the egg and choose the milk, you can have a brownie or a pie. And then juice, same thing. We can have a brownie or a pie. Same thing for the coffee. We can have brownie and pie. The same thing. We can have either choice for each of them. Okay. Oh, that doesn't look very nice. Now, how many lunch choices are there? Well, we can list all of them out. So this is our tree diagram. We can list all the lunch choice out. If you look at the first branch here, if you pick an egg, you can pick a milk, and you can pick brownie. So that's the first choice you can have. Egg, sandwich, milk, and brownie. Now, second choice you can have is this branch. That's egg, milk, and pie. And then we can have egg, juice, and brownie. That's this branch. And then we can also have this branch. That's egg, juice, and pie. And then we can have egg, coffee, brownie, egg, coffee, pie. That's all the possibilities or choices for egg sandwich. Now we also have the tuna sandwich. So TMB, TMP, TJB, TJP, TCB, and TCP. Okay, so these are all the choices that we can have for the lunch special. So that's how many are there? Well, 12 choices in total. Now the question is, what is the probability that your lunch will include milk? Well, where do you have milk? Milk is M, right? So the choice that include milk will be the choice that have M in it. So this one, egg, milk, brownie, egg, milk, what's that, pie? Tuna milk brownie, tuna milk pie. So remember that the probability of something, let's say probability of milk, will equal to the number of milk over the number of total choice. How many milk choice are there? Well, we have 4 choice that include milk. How many choices are there in total? We have 12 choices in total. So the probability of getting a milk will be 1 over 3. Okay. All right, now let's move on to the second example. Second example says Jason rolls a 4-sided die. 4-sided die, so each side will consist of a number from 1 to 4. So that will be, so this will be 1, 2, 3, or 4. And spin the spinner. The spinner is shown here. This is the spinner. We only have 2 choices, either A or B. So the question is, what is the probability of rolling an even number and spin a B? Show your answer using a tree diagram and multiplication. Now, let's use the tree diagram. So, first of all, he rolls a die. So, die. How many choices are there for rolling a 4-sided die? Well, we have 1, 2, 3, 4, 4 numbers, so 4 possibilities. Now, after rolling the die, he also spin the spinner. So spinner. How many choices are there for a spinner? Or how many possible outcomes are there for a spinner? We have A and B, right? A and B, A and B. Okay. So now, what are the possible outcomes? Well, the outcomes are the first outcome, you can roll a 1 and then spin an A, or you can roll a 1 and spin a B, or you can have 2A, 2 and a B, 3A, 3 and a B, and then 4A, 4 and a B. So how many possible outcomes do we have? We have 8 possible outcomes. So now the question is, what is the probability of getting an even number and spin a B? Okay, so let's highlight the even number and the B. So even number will be 2 and 4, right? So 2B and 4B. So the possible probability is, well, we have 2 of these and then out of 8 in total. So 2 of the outcomes that we wanted and out of the total of 8 outcomes, and that is equal to a quarter. So the probability of spinning a even number and a B will be a quarter, 25%. That's by using a tree diagram. Now we can also use the multiplication method. So I want to find the probability of getting an even number and a B. So this is the same as, did I tell you this? To find the probability of 2 independent events, it's equal to the probability of the first event times the probability of the second event. So the probability of even and B will be equal to the probability of even times the probability of getting a B. Now, how many even numbers are there in a four-sided die? Well, we know there are 2 even numbers, right? You can see with a four-sided die, 1, 2, 3, 4, 2 and 4 are even, so 2 out of 4. The probability of getting an even number is 2 out of 4. Now, what is the probability of getting a B? Well, how many choices do you have here? It's either a A or a B. So B is 1 out of 2. 2 choices in total, and B will only have 1 B, so it's 1 over 2. Now, if you calculate that, common factor 1 and 1, so that is equal to a quarter. Well, both the multiplication method and the tree diagram gives us the same probability. That means we're doing it correctly. And so the probability of getting an even number and spinning a B is a quarter, or 25%. Now the next question, let's just use multiplication method for the next question. Okay, so the next, it says you have a blue standard 6-sided die, a blue die, 6-sided, so 1, 2, 3, 4, 6, 5, and 6 outcomes. And the red 4-sided die, so a red die is 1, 2, 3, 4 outcomes. Each are rolled once. Determine the following probabilities. So the probability of the first one says you want blue equal to 4 and red equal to 4. So it's the same as saying the probability of the blue equal to 4 times the probability of red equal to 4. Now, how many outcomes are there for the blue die? Well, it's a 6-sided die, so the total outcome is 6. And what's the probability of getting 4? How many 4s are there in a 6-sided die? Well, there is only one 4, so it's 1 over 6. Now we multiply it by the probability of getting a 4 for the 4-sided die. How many possible outcomes are there? 4. What's the chance, or how many 4s are there in a 4-sided die? Oh, only one 4. If you're not sure, we can write it out. 6-sided die, we have 1, 2, 3, 4, 5, 6. 4-sided die, we have 1, 2, 3, 4. So getting a 4 is 1. There's only one 4 out of the total number of 4s, out of 4. So this is then equal to 1 over 24. So the probability of getting 2 4s from the 2 dice is 1 over 24. Okay. The next one, the probability of getting less than 4 for the blue tile and less than 4 for the red, not tile, the die, red die. So that is same thing, equal to probability of blue less than 4 and red less than 4 times. What is the probability of a blue die less than 4? Well, less than 4, we have 1, 2, 3, 3 possible choices, right? We have 3 possible choices. And how many are there in total? 6 in total. So that's the probability of getting getting a number less than 4 for the blue die. And let's look at the red die. Total of 4 outcomes. And less than 4, we have 1, 2, 3, 3 outcomes. So 3 out of 4. And so this is equal to 9 over 24 or 3 over 8. Okay. Last one. The probability of getting a blue equal to 4 and red less than 4. Blue equal to 4 and red less than 4. Oops. So that's blue equal to 4 times the probability of red less than 4. Blue equal to 4. There's only one 4 out of the 6 sides. Red less than 4. So there are 3 possible outcomes. Sorry, 3 possible choices, and then in total we have 4 outcomes. So that's 3 over 24 or just 1 over 8. Okay. All right, next example. A coin is tossed 3 times. What is the probability of the coin landing tails at least once? So we want to find the probability of at least one tail. Well, let's just write T. At least one T. So the possible outcomes for a coin is a head or a tail. Now you want at least one tail. Well, remember the rule that we talked about last time? At least one tail means it's 1 minus the probability of no tails at all. No tail at all. So if you're tossing the coin 3 times, what combination would you have if you have no tail? Well, no tail means you must have 3 heads. No tail means you must have 3 tails. Oh, sorry, no tail means you must have 3 heads. So now we can just calculate this. We know how to calculate the probability of 3 heads. The probability of getting the first head is 1/2 times the probability of getting the second head is a half, times the probability of getting the third head is still a half. Getting a head from tossing a coin is always half the chance. Okay? So now this is equal to 1 minus 1/8, which is 7 out of 8. Of course, you guys can also draw a tree diagram to see what it looks like. So for example, first time, head and tail, first time. Second time, you can also have a head and a tail. Third time, again, you can have a head and a tail, head and a tail, head and a tail, head and tail. Okay, so the outcomes then will be H, 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 T, H, T, H, H, T, T, okay, so that's a 4, and then the next one, these 4 are from first tossing a head, and then we can have tail, head, head, tail, head, tail, 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 head, tail, tail, tail. Okay, so the question is at least one tail. At least one tail means you must have at least one T in the outcomes. So that's 1, 2, 3, 4, 5, 6, 7. 7 of them. So it's 7 possible combinations out of 8 total outcomes. Okay, so you can have 8 outcomes in total, 8 possible combinations, but for the combinations with at least one T in it, you have 7. So it's 7 out of 8. 7 out of 8, which is the same as doing it using multiplication. Okay, last page. Example number 5. It says a bag contains 2 black balls and 1 white ball. If a ball is randomly selected and not returned to the bag, not returned to the bag. What does that mean? Well, it says randomly selected, not returned to the bag, and then the second ball is randomly selected. So would this event be dependent or independent? Well, it will be dependent because the first event affects the second event. Right? You taking one ball out of the bag and not returning it. So the second time you choose a ball, there's only 2 possible balls that I can choose from. Okay, so now I'll ask you to use a tree diagram to show the possible outcomes. So first time, first selection, second selection. First selection, you can have a black ball or a white ball. In the second selection, you can have a black ball or a white ball. But if you choose the white ball at first, how many balls are there left? There are 2 balls left. And what are they? They're all black balls. So you can only have the black ball. Is there a chance that you're getting a white ball? No. So let's write down the chances of getting the balls. So the chance of getting a black ball in the first selection is 2 out of 3 because you have 2 black balls out of a total of 3 balls. And the chance of getting a white ball is 1 over 3. Okay? And the chance of getting a black ball in the second time, if you choose the black ball in the first time, is half. Why is that? Because after you've chosen the first black ball, then what's in the bag, what's left in the bag is a black and a white. So the chance of getting black is half, and the chance of getting a white is half as well. Now look at the second branch here. If the first ball you pick is a white ball, then in the bag you would only have black balls left. Okay, so the chance of getting a black ball is 2 over 2. 2 black balls you can choose out of 2 total balls. Okay, and what's the chance of getting a white ball? Well, it's 0 because you can't get any whites. There's no white left, right? Okay, so let's list all the possible outcomes. Well, we can have a black, a black, a black and a white and a black. But can we get 2 whites? No, that doesn't work. Now, what is the probability of selecting 2 black balls? Probability of selecting 2 black balls. So B and B. Well, you can see that out of the 3 possible outcomes, BB is 1. You can only have one outcome of both black balls, and out of 3 total outcomes. That's from the tree diagram. Or you can also use the multiplication method. So probability of BB is equal to probability of getting the first B times the probability of getting the second B. Maybe it would be easier, it would be better if I write first B times the probability of the second B. Well, the probability of getting the first B, we know it already. It's 2 out of 3 chance. And probability of getting the second B is a half. So if you multiply it, it's still equal to a third. Okay, it doesn't make too much difference. Well, it doesn't make any difference at all, because these 2 methods can be used interchangeably. You can either use your tree diagram, or you can use this multiplication. Now, example number 6. 2 cards are selected from a deck of cards without replacement. Without replacement, again, here, without replacement means you're not putting the cards back. So this will be dependent event. Now find the probability of getting 2 A's. Probability of getting 2 A's. Well, the probability of getting 2 A's will be the probability of getting an A and then probability of getting an A. So the first time you get an A, how many A's are there in a deck of cards? Well, there are 4. And then how many cards are there in a deck? Well, 52. Okay, now you've picked 1 ace. Now, the second time you want to choose an ace. What's the probability of choosing an ace the second time? Because you've picked out a card without replacement, that means your deck is now became 51, not 52 anymore, because you picked 1 already, right? And what about the number of A's you have in the deck? There's only 3 because you picked 1 already. Okay, so this is equal to 4 over 663. That's the probability of getting 2 A's. Now let's look at the probability of getting an ace and the jack. Ace and then the jack. So the probability of getting an ace and the jack is the probability of getting an ace times the probability of getting a jack. Well, to get an ace, we have 4 A's in total in the deck of 52 cards. And how many jack do you have? We'll have 4 jack, but this time it's the second time you pick a jack, right? You pick the jack. the second time after you've picked the ace. Now, since you've picked ace already, the deck of cards will become 51, not 52 anymore, because you're not replacing the ace back into the deck. So it's 4 over 52 times 4 over 51. That's the probability of getting an ace first and the jack next. So, oh, whoops, sorry. This is equal to that, and the first one is equal to 1 over 221. Okay, last one. What's the probability of getting an ace and a jack in any order? Ace and jack in any order. In any order means you can get ace and then jack, and you can get a jack first and then an ace. Well, so we find the probability of each one. The first one, ace and then jack, we found it already. It's over here. So that's 4 over 52 times 4 over 51. Now, what is the probability of getting a jack first and then ace? To get a jack with 4 jack in total out of 52 cards. And then an ace, we have 4 aces in total, but after you pick the first jack, you only have 51 cards in the deck. And so if you add these two, they're actually the same probability, right? So if you add these two, you get 6 over 663. Okay, so that's it for today's lesson. Please try the homework questions up here on section 7.7 and let me know if you have any questions.